All right, we can start now. So this is the one presentation which is beyond PostgreSQL 17, 7 DBA workarounds for enhanced management, right? Again, the focus of this presentation is that we always talk about great features, great capabilities of PostgreSQL. In this, what I will try to cover, the limitations we have, right? And what are the different workarounds one DB has to implement when they're using PostgreSQL in production. And I will try to cover those use cases, and let's see how we can move forward on that front. So before going further in this, I would like to talk about me. My name is Vibhor Kumar. I'm also a co-author of a book called PostgreSQL 16 Administration Cookbook, which has a lot of recipes. It's a cookbook, which you can use it in your production deployment of Postgres, managing, maintaining the PostgreSQL. With this, I have expertise around cloud technology, microservices. You can name any database which I've worked on it, right? MySQL, DB2, EDB, Postgres Advanced Server, Oracle. I've worked on all those different technology, right? I've also written a multiple security best practices white papers, which you can find it on our website. About my company name is EDB Enterprise DB. We are very well-known contributors in the PostgreSQL community. We have nearly 800 employees, and we have also migrated almost, or maybe more than 50,000 Oracle schemas to the Postgres in our tenure, right? We have one product called EDB Postgres AI. It's a one product which we sell, one company, one product. And this product is really a platform where you can actually leverage PostgreSQL in different use cases. So far, people have used PostgreSQL only for transactional workloads, right? But let's say if you want to use PostgreSQL for analytical workloads, you can use it. If you want to use PostgreSQL for AI ML, right, or AI workload, we actually help our customers to do that. We have that platform which enable it. And then if you want to use, or if you want to build a Postgres Lakehouse, so we have a Postgres Lakehouse too. How many of you are familiar with the Lakehouse? One person, okay. It's a data lakehouse, okay. All right, so lakehouses, people actually talk about petabytes of data which you want to maintain through one technology. How many of you are familiar with Databricks? 3 people, okay. It's again Lakehouse solution provider. Okay, so we provide Postgres Lakehouse. So you can think about this way, Postgres interface you're familiar with, right? Whatever application you have built using JDBC driver, PSQL, of course we have a JDBC contributor here and committer. So JDBC driver which you use with the PostgreSQL, you can use the same interface on analytical platform on Lakehouse, right? You don't have to change anything at all. That's the beauty of the Postgres Lakehouse. Okay, it's purely secure, compliant. So whatever compliance requirement you have will be pretty much baked into this platform. So when I'm talking about Postgres platform, right, this is the one unified workload management system, which has transactional, analytical, and artificial intelligence capability. We have two kinds of AI implementation. One is called artificial intelligence for database, where you can actually offload certain activities to the artificial intelligence to take care of that part in the database. And second is called database for AI, like PG vector capability, which we talk about, or machine learning capabilities or models, which you can use it in the RAG format, right? That ability is there with EDB Postgres AI platform. We enable our customers to use EDB Postgres AI platform on all the cloud service providers, like you can see AWS, Azure, Alibaba Cloud. With this, we also provide the same DBAS experience, database as a service experience, with EDB Postgres AI platform on-prem clouds, with the help of Red Hat, IBM, Supermicro, or Nutanix. When you talk about what we offer, EDB offers single pane of glass, right? Which is like where you can see all your Postgres state, whether you're running Postgres on a cloud, on-prem, or any cloud service provider. You'll get the full visibility of those installation. We provide enterprise-grade support around the Postgres. That includes the 5 nines of high availability. You can manage, maintain hybrid cloud service providers capability too, using our single pane of glass, and of course, other use cases which we cover called analytics and artificial intelligence. This is we provide through our analytical and accelerator technology, which we have baked into our hybrid control plane. These are some customers whom I'm highlighting here. You can see that all the different sectors, they're using enterprise DB technology. Whether we talk about BFSI, banking, financial services, when we talk about technology vendors, they're also using EDB services, or if we talk about telco, cloud service providers too, they use EDB services too, right? So that was all about EDB. And here we are going to talk about the EDB contribution to the PostgreSQL 17. These are some key contributions from our side, which really focus on not only about managing, maintaining the database, PostgreSQL, it's also helping our developers to do more with the technology. So that's why you can see the JSON-B or JSON table capability, SQL JSON capabilities which we built in PostgreSQL 17 is through EDB. When we talk about logical application, EDB also added actually a lot of capabilities in that. We simplified the complex logical replication capability. Of course, we added the PG create subscriber, a binary which you can use it to automatically add logical applications or logical standbys to your PostgreSQL instance. Right? So that was all about EDB contribution, EDB. Now let's focus on the main topic of this session. 7 DBA workarounds for enhanced management. And as I mentioned that, what I'm going to cover are the different use cases, challenges, which one DBA faces, right? And what are the possible solutions around it? And of course, in EDB, what solutions we offer, right? First important challenge people, face is around zero downtime rolling major version upgrade, right? How many of you are familiar with a major version upgrade or processes they have used in the past? Okay, and how much downtime you have to actually take for doing the major version upgrade on an average? Sorry? 8 hours, yeah, that's one, yeah. 8 hours, yeah. Anyone else? It might take more too, right, depending on the size of a database. And that actually prevents people to use PostgreSQL for critical application, right, where you cannot bear downtime. You cannot afford any downtime because a critical application, if the application is down, it means you're losing the business, right? So that's why zero downtime rolling major version upgrade is a key thing. And DBAs always think about that, how they can achieve it, right? And as you can see, how you can do that using logical application. When you talk about the architecture, this is a very standard architecture you can think about, right? You have a one primary, 2 standbys, certain configurations which you have to put in place, right? Using this basic architecture, you can have a one more drive architecture, where you can have within the region, right, in the data center, right? Or you can have one Postgres, multiple standbys. In the same fashion, across the region, you will have the cascaded replica, right? So this is a very standard HA architecture. And when we talk about major version upgrade, you need to actually bring down each nodes to do a major version upgrade, right? And there are different mechanisms or methods are available which people follow it, right? Now let's talk about the zero downtime upgrade essentials, which is like an important piece. What are the important factors you have to consider? One is that minimizing the downtime, that is you can only afford milliseconds of downtime. You would like to ensure that when you're doing the major version upgrade, there should not be any data loss. And whatever changes you're putting inside the database, right, should be there, right? These are the important key requirements. And post-upgrade, right, of course you're doing a major version upgrade. Post-upgrades, you need to have a backup plan. In case your application doesn't behave properly, you should be able to go back to the old version and fix the new version and come back, right? There are a lot of moving parts here. And if you talk about the options, there are certain options people use it. The old way of doing things is pg dump, pg restore. It's a very clunky, old way of upgrading. What people do, they actually spin up a new instance of the PostgreSQL or new version of PostgreSQL. They dump and restore the data. It's a very tedious process. It takes good amount of time. 8 hours is one example. Sometimes it can take 36 hours too, right? It's a huge downtime. Second, people can also use PG upgrade. In PG upgrade also, you have to bring down the primary. Post upgrade, what you do, whatever changes of the files, right, you replicate that using rsync command on the standbys and then bring it up. But still requires downtime.
Also, you do the analytics. So even if you do PG upgrade, you still have to vacuum out or analyze your whole DB.
Yes. Correct, yes. Yeah. Sorry? That's changing, yes, from 18 onwards. Yeah, but still, when you talk about the PostgreSQL 17 or current versions we have, right, when you upgrade, you need to perform analyze operation to make sure that you get the same performance what you had with the previous version. Okay? Now, a question comes, how can we actually reduce this downtime and ensure that our system is up and running, right? And then again, question comes, exactly what kind of a backup plan you can put in place so the major version upgrade should be smoother, and in case you have to roll back, you can roll back too, right? That's why the native logical application comes in. There are some key improvements happened in version 17, which makes it a very prominent solution, right? This first solution is that when you do a major version upgrades, right, you also need to think about what are different data streams are really streaming the data from your database, right, through logical application slots, for example. So far, before 17, when you do a PG upgrade command, right, in that case, you will lose those logical slots. You have to restart it, right? Resyncing of the data is also a tedious activity. To ensure that whatever operation you have in place should work correctly, that's why PG upgrade preserves application slot in 17, which is a great thing, right? Second is that you need to have a failover control over failover slots too, right? If you're using some slots on a standbys, what will be the impact of those slots, right? Like sometimes people have a HA availability with the standbys, and those standbys are getting used for other purposes, like streaming data, pulling data directly from those standbys to maybe an analytical platform, right? Where you can use that data for analytical purpose. So that's one more thing. And of course, PG create subscriber command also helps you to actually convert a one standby to logical standby. So you can see these are the important features which makes native logical application important technology which you can use it for almost zero downtime upgrade, right? So this would look like. But here we're talking about the logical application right now. So some use cases I've already covered, like selective replication, cross-platform flexibility, like if you're going from Windows to your Linux operating system, or if you're going from cloud to your on-prem cloud, you can do all those kind of replication. It can also be used for maintaining the tenant apps, right? Data integration can happen. Whatever data you're modifying in one system can also replicate there. So these are the fancy capability of the logical application, right? And that's why it makes it one important technology which you can use it for the major version upgrade. Now, in case of major version upgrade, what do? You actually have seen that this kind of architecture, right? Within the data center, you have primary standbys. Across data centers, right, you can use logical application to move the data. Now, in this architecture, what you can do, you can actually take US West and do a PG upgrade, bring it up, and start syncing the data again. When US West is pretty much upgraded, you can move your application to the US West, and you can do the same thing in the US East. And you can bring back the data here, or bring back the application to the US East one. So this is the way you can actually reduce the downtime, right? It looks very good in theory. This architecture looks good in theory. The challenge is around how would you ensure, right, whatever changes happening on your US East one is also getting replicated to the US West to West, right? Because there are certain changes which you cannot do with logical application. Like for example, schema changes. Whenever you add a new table, when you modify a structure, that structure cannot be replicated by logical replication, right? So that's a thing which you have to keep in mind. And again, these are the limitations, but you should watch for it, right? Second is that when replication is going on between publication and subscription, right, what will be the impact on your primary, right? That you have to keep in mind. Third thing is this: when you do a failover on the US West, how would you come back? Because you have to again do some manual activity or maybe run some commands to make sure there is a reverse replication going on post-upgrade as your backup plan. And that would also, you have to keep in mind that from which logical sequence you have to bring or start the replication. Those things you have to keep in mind, right? So you can see there are many challenges, but it is achievable, right? Other part is that node consistency. You have to monitor both the nodes to make sure that both nodes are consistent. That is, you have to monitor the replication going on between the nodes, right? Or structure change happens, something happens. You also have to worry about your connection routing too, right? You have to ensure that by mistake, if there's a new connection going on the US East, right, and it's writing some data, that data will not be available on the US West post-upgrade. So those are the things you have to keep in mind. And again, if there is a conflict happens, some conflict resolution should be in place. But still, it's doable using the logical replication. It's not a silver bullet, but it's doable. And that's why EDB has built a solution called EDB Postgres Distributed, right? In this, there is a bidirectional application going on. This technology would allow you to, of course, do one node at a time upgrades, right? Or you can do one region upgrade, then go to the second region. And here you can see, even applications writing to the US East 1, that data will also be available on the US West. And it will reduce the effort of doing the reverse application. Yeah? It takes care of the slots and everything for you. So what it provides you the ability to replicate schema changes, the replication management. You don't need to focus on that part because it takes care of everything for you. It has a parallel apply capability, which can replicate the data quickly for you, right? You can replicate or you can write on both the sides. So even if you have, if you did a connection failovers to the US West, right, whatever you're writing there is already available on the US East too, okay? So it covers all the node consistency too. So whatever new data, column change, whatever you do, it maintains the consistency across all the nodes, right? Connection routing capability is baked into the PGD. So you don't have to worry about managing those connections at the application layer side or through your connection poolers or through your load balancers, right? It's there inside the PGD. And you can use the inbuilt conflict resolution capability to maintain the consistency across the data centers, right? Now, using that architecture, you could also build up one more architecture using the PGD, where each node is a read and write node, right? Where you have a logical standbys. You can see in this architecture, right? So the PGD proxy, which you see, it's actually part of your database. It's part of the PGD, Postgres Distributed. So it gives you added advantages. Advantages like, for example, if you want to perform a vacuum full operation on a single table, you can go to the maybe location B, where you can perform vacuum full operation, right? Or you can do reindex, whatever you want to do that, right? You can perform that operation, let it synchronize, and you can route connection to the location B. You can go to the location A, you can do the same thing, right? Because all the data is getting replicated using the logical replication capability, which is again beneath that Postgres Distributed. Okay? As I mentioned, the advanced capabilities, connection routing, load balancing, you can also do a selective replication, you can do blue-green deployments, right? These are the important features of the PGD. So that's also one way you can achieve minimum zero downtime upgrade with this more flexibility with the architecture, right? Second thing comes where DB actually always think about, right? Like sometimes you must have noticed that in production environment, somebody will go and drop the table, and they don't know what will be the repercussion of dropping a table, right, in the production. For example, if you have a procedure which is referencing that particular table, how would you identify that? That's a challenge is always be there with the developers and DBAs too. When they roll out any kind of a code changes, they have to find out dependencies of those code changes and what will be the implication or impact on a database, right? So, and for example, let's say, suppose somebody wants to drop a table also, or suppose somebody wants to drop a function too. What will be the impact of that function in the database, right? So all those things are there, and that's why, as a DBA, you would like to find out an option which you can use in production to review all those changes and ensure that you take the necessary or proactive actions to maintain the consistency of your database, right? So, why DBAs need this? Again, one is that they want to validate the code integrity. You have a lot of procedure functions inside the database, right? They also want to assess the change impact. If there is a small changes goes inside the database, whether it's a schema change, procedure change, what will be the impact on a database itself, right? That's an important thing. They also want to visualize the dependencies across these objects, right? Like in PostgreSQL, when you write a function, there is no direct way to identify the dependencies of the object on that function. How many of you are familiar with the Oracle? One. Because in Oracle, you have the ability to see the dependencies, right? And that's not there, right? And again, proactive risk mitigations too. Like if you modify a particular, if you drop a table or if you drop any view, right? And let's say your application is using a function which is heavily reliant on that view, it will start breaking, right? So it's very, very important. So in that case, there is an extension called PLPG-SQL check, right, which you can use it. And this slide shows you exactly how you can install it and deploy it, right? There is a very important function comes with a PLPG-SQL check. That's called PLPG-SQL show dependency table. There is one variant of that, but table actually is going to give you a tabular list in which it will show you what are the functions, procedures are dependent on each objects, what are dependent tables, sequences, other things. You will get all those information in nice table format, right? So let's see. This is one simple example of how you can use this particular PLPG-SQL show dependency table, right? There are some smart DBAs or smart developers also. They actually bake this kind of a check directly into the GitHub Actions. So whenever they want to roll out any releases of the schema, it actually automatically, the GitHub action, perform this kind of a checks using these functions, right? And it will error out and you can go and fix it, okay? Another one is called get dependency tree. This will give you the whole dependency information about the object. A tree-like structure which you can get directly from this particular PLPG-SQL function. It's a great technology, and I also have some SQL queries baked or built around this particular extension, which you can find it on my GitHub repository called EDB-SPL-SQL, and there is a SQL called dependency tree SQL. So you can use that SQL to find all the dependency or create a dependency tree of functions or procedures, right? Here's an example. It might not be visible to you, but what it shows you, caller function which if you call it, right? And what it's calling, right? What kind of an object is calling, and what is the procedure type, whether it's a procedure, function, whatever it is, right? And you can create a nested loop also. Like for example, function A is calling function B is calling function C is calling function D, and D is dependent on a view, right? You can build that kind of a dependency too, very smoothly and very easily. So this actually gives you ability to be more proactive on finding all those issues before you roll out the schema changes in your production, okay? It also helps you to do a code quality and performance checks too. So PLPG-SQL function comes with called PLPG-SQL check function. So let's say if you're writing a function, right? And you know that if you run this function, it will go and update certain tables and data. But you want, before running it, you want to do a dry check, right? For dry check, you can use PL/PG/SQL check function. What it does, it actually shows you, it gives you a lot of information here, right? Where is the syntax error, right? Which you would like to fix it with giving the line number, right? It will also tell you that if you're over declare the variables, right? Some variables you might not be using it, but it's already declared there, right? Which is again bringing the inefficiency in the code. You would like to remove that inefficiencies. That's right, bless you. And then there is also called performance check too, right? You can use PL/PG/SQL profiler function, where you can put your function name, and it will tell you each statement, how much time it's going to take. And accordingly, you can work on tuning those each and every statement of your code, right? Very efficient technology. So you can see this is an example where it shows you many different error messages, right? It also gives you some kind of a recommendations too, right? If you use indexes on a specific call or specific object, right, table, right, then it'll be good. From performance perspective, what you would like to use, you would like to make it more volatile, it should be stable, right? So these are some recommendations also coming out from the PL/PG/SQL check extension, right? Right. It can also help you to identify any security vulnerabilities in your code, right? Interesting, right? It's amazing. So you can look at it and you can see it will tell you that execute type variable is not sanitized. Go and work on it. It will give you detailed examples what you would like to use it so that you can improve your code from that aspect. So that was all about dependencies and other things, right? Now the third thing which DBAs always worry about is called automated PostgreSQL tuning. Let's see how much time I have. Okay, this is the important piece. If you're rolling out PostgreSQL more often, right, you want to make sure that you roll out kind of an optimized instance of the PostgreSQL. And that's why it's very, very important. You have so many PostgreSQL running in your environment, you would like to ensure that they are optimized properly. Going one by one is challenging. So you would like to bake the deployment procedure, or maybe you would like to bake something in a deployment procedure. When it deploys the Postgres, it should also further optimize it, right? That's an important requirement of DBAs, right? So here you can see the manual challenges always, manual tuning is always has a lot of challenges around it. Because workloads are changing, because of the workload change, you need to think about scale based on which you would like to optimize your hardware and PostgreSQL parameters. And third thing is, of course, you want to ensure that you have a consistency across your deployment. And again, benefits of the automation, I think you're aware of that, right? It reduces the effort. You now don't have to go one by one each instances and optimize it, right? So, and of course, if you're picking one instance at a time and manual interventions are there, you might actually by mistake make some different kind of changes which will have a side effect on your Postgres instance, right? So we know all those problems. So that's why we have a technology called Trusted Postgres Architecture tool, TPA tool, which allows you to actually automate the tuning of the Postgres instance, right? It maintains the state of each deployment. And through that state, it goes and monitor it and deploy it correctly, right? What it can do for you, it can provision servers for you. If you're running in AWS, EC2 or Docker, it can configure or optimize operating system for PostgreSQL. It can install PostgreSQL for you, and it can run an automated test to ensure that everything is working correctly. So everything is pretty much baked into the TPA, which is called Trusted Postgres Architecture. So it's going to deploy a whole architecture for you, right? And how do we use it? You can see that there is called different options comes with the TPA. One is called configure. When you use a configure, it actually gives you a config file for you. You can go and choose exactly what you want to deploy. So here you can see what we are trying to do, we want to deploy PostgreSQL 15 architecture M1, which is primary and standbys, right? And we want to use Patroni. How many of you are familiar with Patroni? Okay. Patroni is a technology people use it for automating and management of the high availability of Postgres, right? But behind the Patroni, of course, it uses many different things. etcd for maintaining the quorum. It uses streaming application for high availability, and it takes care of many other parts, aspects of logical slots and other things, physical slots and other things, right? So what we are doing, we are asking to deploy one physical, 2 standbys, that's called M1 architecture, with PostgreSQL 15 and enable Patroni, right? And then it's going to create a one config file, and then you can use TP-exec provision to create those servers, virtual machines in the cloud, and then deploy it, right? Straightforward. So now what you can do, same architecture, you can deploy everywhere, and TP automatically, out of the box, tune the systems based on the resources available on the system, right? TPA can also deploy PGD always-on architecture too. Here is a complete command. You can see that many different options. One I've shown you with the Patroni. When we say failover manager, it supports EFM, it supports Red Manager, it supports Patroni. Okay? And these are important commands which you can run it. Post deploy, you can test it also to make sure that everything is working correctly before you hand over that cluster to developers to work on it, right? And other technology which we have called ADB Postgres Tuner extension. As you know that when you have deployed a Postgres in production, right, workload will change over the period. When workload changes, you have to make sure that you're monitoring it, and you are optimizing the Postgres instance to give a better performance with the workload change, right? That's why there is a technology called Postgres Tuner extension which was built, right? And this is again available from 15 plus. It's an extension which you can deploy it. And here's the command which you can use it, right? You know, share preload libraries, a parameter in the PostgreSQL, where you can include EDB PG tuner, start the PostgreSQL, and that's it. So what will happen? There is intelligence now in PostgreSQL, which is monitoring your workload and optimizing it, like work parameters for you, okay? There are certain parameters comes with that, because sometimes people are scared of actually enabling this dynamic tuning in the production, right? But they want some suggestions so that they can go manually and update those parameters. Plus, they also want to make sure that they have audit created, somewhere they're storing the changes too, right? So those abilities also possible through EDB Postgres Tuner. By default, auto-tune is false, but let's say if you are okay with tuning the system automatically, you can enable it. There is an app time based on which it actually comes and go, and optimize the parameters or give suggestions. Those suggestions you can trace it in the log files or can see on the screen too. And then there's called max wall size limit again. You can mention that if particular limit happens, right, or based on a workload, let's say if there is a huge insert update that is going on, more wall files will be generated, right? Then you can actually control that behavior using this setting called EDB PG tuner to throttle that kind of a max wall size through PG tuner. So here you can see what it would look like. For example, let's say if you have auto tune or tuner off, but you want to actually ask PG tuner to tell you exactly what are the changes you would like to push in a database, you can call a function called ADB PG tuner recommendation. So it's going to list out the recommendations for you. It's not modifying anything, because it's monitoring the workload on your Postgres, right? And if you want in a SQL format, it will give you alter system commands too. So that was about the automatic tuning. So you can use these two technology together. So it's, the impact will be very minimum. That's the way it's designed. And it's based on actually sampling of the queries. It also uses the pgstat statement behind the scene to trace those queries, understand the behavior, right? And accordingly gives you recommendations. So overall, whatever is inside the Postgres, try to leverage that instead of creating something new. That's why it's a minimal impact. Okay? Now, another part is called online vacuum fill, right? You know that the way MVCC is designed in PostgreSQL, it results into the bloating of the tables, or bloating of a database, right? And here and there, people will tell you that you have to actually run vacuum fill if you want to reclaim the space, right? Vacuum is efficient, for sure. Auto vacuum is great too. But sometimes you have to run a vacuum fill too, right? And that's why there are other technologies available which can help you to do that, right? Well, why DBA wants online vacuum fill? Because when you run a vacuum fill, it locks the table. And any critical application using that table will not be able to perform its operation, right? And in that case, it's kind of a downtime for you, right? It reduces the maintenance downtime. It also improves the user experience because application, if you have online vacuum full availability in the PostgreSQL, right? Then in that case, your application is not down at all. It's always available for your users to use it, right? So there are technologies available for you. One is called PGSqueeze. I like PGSqueeze over PGRepack. PGRepack is also very well. How many of you are familiar with the PGRepack? Okay. Great. Okay, 10 minutes left. Okay, all right. So I'll go fast now. Okay, so PGSqueeze is another technology which you can use it. The best part of the PGSqueeze is that you can submit a job saying that perform a vacuum fill inside the database, perform a vacuum fill for this particular table. And behind the scene background worker will start, will perform those operations for you, and you can get back, or you can come back and just check the status. That's the beauty of the PGSqueeze over PGRepack. PGRepack requires a client always connected to your database performing those operations, right? So you can think about if the network break happens, something happens, right? Then you have to restart the whole operation. But in case of PGSqueeze, you don't have to do that because it's an extension, lives inside the PostgreSQL. You submit an operation, you can come back, check the status, right, and it will keep going. Another part is that when you take a backup, you take the whole system's backup, right, and you can restore it accordingly too. So that's the beauty of the PGSqueeze. That's why I like it better. Second is that PGSqueeze behind the scene uses logical decoding instead of using triggers. PGRepack uses triggers, which is an expensive operation, right? Installation is very straightforward. You can see that. You can simply install the PGSqueeze 16, RPM, update the shared preload library, right? You need to have a wall level to logical, and you need to have a max slots more than one, at least one for PGSqueeze. So you have to keep that in mind. And then you can do create extension PGSqueeze, right? For squeezing a table, you can simply use insert command. There is a squeeze.tables, which comes with the PGSqueeze. You can insert a table name, right? And that there is a format in which you can mention that when you want to start this online vacuum full operation, right? This is like a cron tab syntax which you can use it. Okay? Then on demand, of course, PGSqueeze, you can use it. There's a squeeze table function which you can use it to submit. Let's say if you want to do, instead of scheduling a job to do online vacuum full, you can actually do a real-time ask to using squeeze table function, right? And there is a squeeze.log, a log table through which you can find more details. What is the stage of your vacuum full? Great extension, right? Helps a lot. Now, the fifth one is the people want AWR-like reports. Right? Those who are Oracle users, they actually used to get performance information through the AWR report. Right? That's also one requirement of the DBAs. Because this report actually gives you the insight of your current state of your database, right? Exactly what are the queries which are performing slow, what action you would like to take. And if you have multiple reports, you can compare. This way you can find out what changed over the period, right? Or you can do a pattern analysis too. So that kind of a requirement is from a DBAs. I won't go through this whole thing, but that's the essence of this AWR report. A report which can give you the insight of your Postgres instance, which can tell you what are the challenges you have right now, and it can help you to tune the system properly, right? Which can give you the comprehensive information around the wait events, SQL performance, which can give you the historical analysis of your database, and based on that you can tune certain parameters. And this is called PWR, not AWR, PWR. Postgres Workload Repository or Workload Report. Okay? Here you can see another snapshot of that. And you can find more information from that link. Other sixth one is called Job Scheduler. 5 minutes. Okay, I'll go fast. Job scheduling, right? It's also an important piece. A lot of people actually rely on the external tool to schedule the jobs on the PostgreSQL, right? Which is good. You have a central management system through which you can run any kind of a job, insert, update, or any operation you want to do, right? But it has some limitations because the external or PG agent which is running next to your database, right, may be slower because of network latency or other purposes, right? And second is that you also would like to ensure that whatever job which are part of your business need, right, is there when you restore the data from the backup should be there too. That's why you would like to keep that job inside the database. So when you back up a database, the job is also get backed up automatically. So you don't have to worry about identifying the jobs which you have to schedule it post-restore. When you restore the database, the jobs will also get restored for you. That's why PG cron is one of the important solutions which we recommend, right? It's already part of your database. You can schedule those jobs, and again, it follows the cron type syntax, right, for scheduling the jobs. Installation is very straightforward. Again, RPM, shared preload libraries. There are certain parameters which you can set it. Cron.database name, where you can mention which database is going to keep the information of the jobs. And you can also use any kind of a time zone, right? You can schedule a job, you can unschedule a job. You can do both the things using a SQL select interface, right? Or SQL interface. Very straightforward. It's there inside the database. You don't have to worry about restoring the jobs post-restore of a database, right? When you back up everything. The last thing is called cloning schema, right? This is always comes in when you are deploying Postgres based on your tenant's requirements, right? Or if you're in a multi-tenant environment, if you want to onboard a customer, sometimes you have to recreate schema using a golden image, right? That's why DB clone schema is very, very important. There are different solutions available, right, for cloning a schema. Sometimes people use pgdump, pgrestore. Some people do a storage snapshots. Some people use native logical application capability, right? Using formatted wrapper, you can clone the whole schema, right? But each one has some limitations too. Like storage snapshot means you're snapshotting the whole database, bring it back, take out the particular schema and restore it, right? Or maybe rename it. pgdump, pgrestore also doesn't have the ability to modify a schema. Let's say if you want to clone a schema A, right? And you want to clone it as a schema B or with another name, it's very difficult and tedious activity. You have to write a script which can pass through your schema name, modify it, and then restore it, right? Expensive activity. That's why we have a technology called EDB clone schema. Here we're talking about some important tricks. Here you can see how you can do with the pgdump, pgrestore. You can see what you are doing actually. You're first taking out psql dump, pgdump, right? And then after that you can restore it. Or you can use set commands, right? Set commands, you can use it to rename a schema before storing inside the database. And then you can see these are very complicated ones, right? But even these options doesn't guarantee that everything is properly following the format. Let's say, for example, when you're storing a schema, there's a function, and function is referencing a table with the schema name. It will be a challenge. You have to pass to the function, change that schema name, then only you can restore it, right? With the different names. Yeah, these are some examples which you can use it. So what we do, there is a technology called EDB clone schema, which can actually help you. It gives you a functions which you can use it. Again, deployment is very straightforward. You can update and you can create extension commands. Here's an example how you can use this technology called edbutil.local schema, where you can mention formatter wrapper which you would like to use, mainly from connectivity perspective. You can pick up the source schema. You can mention a target schema. You can also mention the log file name, where you would like to look at the activity, how it's going on, and you can submit it, right? This comes with the two different options, local copy schema and remote copy schema. You can copy a schema from a local database to remote database, or remote database to local database, or within the database itself. It has also an option called process status log to see how the job is running, whether your schema is cloned properly or not. Okay? And that's it. So these are 7 DBA workarounds. Okay? You can scan me.
Real quick, sorry to interrupt. Our reception is going to start at 5 p.m. on the South Courtyard. So if you're welcome to go down there when you're ready. But because this is last session, we do have a little time for Q&A.
Yes.
So I'd like to let you know, but you can go ahead and take
Go ahead. Yeah, that's why I just finished it. Now you have enough time. Yeah, any questions? Yeah.
For the tuner, assuming you want the recommendations, is it possible to get a rationale behind why it's recommending a value?
Yeah, that details is not there, but overall, yeah, that details is not there. I see what you're saying, that if it's giving a recommendation on changing the parameters, right, it should be actually showcasing that based on these information, it's saying that. Therefore, certain parameter changes, yes, you will not be able to find information, but we are working on it, because that's kind of a thing everybody wants, a report which could showcase exactly why this parameter would be important for your database. But it can also give, but other than that, there are other recommendations like creating indexes on a table. Those pretty much is backed by the pgstat statement and queries which it has observed. So yeah.
I'm thinking about, for example, let's say it recommends you increase your shared buffers.
Yeah.
It'd be nice to know why. Like, did it see cache misses or something, or did it just look at the total RAM?
Behind the scene it does all the things, but I agree with you. Yeah, it should give you the facts, right, based on which it has recommended. It's a good thing. Yeah, we are working on that front. So maybe the new release will have that. Oh, these two? Really? Okay. Oh. Blog, scan, and LinkedIn. No, it's not working. Okay. That's interesting. Maybe I will fix it later. Okay. But you can Google me. You can include my name, Vibhor Kumar Postgres. Only three words. And you will find me on top of that. Yeah. Yes. I'll publish that.